Axion is where motivated light dark matter, which is the typical mass carries 10 to the minus 6 electron volt, especially the some of the QCD action. And also the motivation of the action is to solve the strong speed problem, the QCD. So today I will talk about some of the three topics in the axion physics. First of all, the one thing, the strong speed problem, and the second one is the action potential. Because the action was one of the shooter's color build, so the suggest color potentials can be constructed. And the third one is some of the very brief reviews about the action cosmology, how the action becomes a dark matter. So first of all, let's talk about the strong speed problems. It comes from the U1A problem, where there's some of the chiral symmetry. The QCD has the following global symmetry, not asymmetry, it's the global symmetry, SC3L left-handed for the fermions and SC3R right-handed for the fermions. That's the 3 plus that comes from the up-down Swansea which is some of the light cook below the scale of the QCD scale. And the U1L and the U1R for the left-handed and the right-handed spinors respectively for the phase factor exponentials are, etc. This is a global symmetry, not the gauge or internal symmetry. And such a global symmetry is actually the spontaneously symmetry broken. So only the remaining symmetries are just the S3V factor symmetry, which has a different pace for the left-handed and the right-handed. Is the neo gamma pi matrix is in the exponent as a generator, and also the U1 V factor symmetries remain. So there are 8 generators, and one generator is broken. So the 9 mesons appears as a Goldstone boson. And by using the chiral perturbation theory, we can obtain the mass relation between the such a 9 mesons. But the problem is the one meson, eta prime meson, does not satisfy the mass spectrums that comes from the chiral perturbation theory. So it means that the U1A, such a chiral symmetry or axial symmetry, is the not two symmetries of the QCD. And actually, this U1A axial symmetry is anomalous by the triangle diagram, which is not the anomaly. And we can draw the triangle diagrams with the 3 external line. The one is some of the axial current, J mu 5, and the 2 things are some of the gluon. And by this anomalous triangle diagram, there are some of the theta terms that appear, which is twice of the gluon field with its dual. And such a theta is also called the strong CP paste because it makes the CP violations in the QCD. And by using the chiral perturbation theory, the Lagrangians contains some of the such a Goldstone boson field U, which is parameterized by the theta terms and the pion decay constant F pi. And the such N is a neutron doublet consisted by the proton and the neutron. By expanding such a chiral perturbations theory of the Lagrangian, we can obtain the coupling between the pi meson, pion, and the nucleon doublet. And it means that such a diagram is possible, even though the neutrons does not have the electric charge, because it can be coupled through with the pion. So such a loop is possible, which makes the neutrons electric dipole moment, neutron EDM. So such a neutron EDM is possible by such a coupling between the pion and the nucleon doublet. And such a coupling is proportional to the theta term over the pion decay constant, phi, and the mass of the cork. But the experimental observation, such a neutron EDM just strongly bound. The neutron EDMs from such a coupling, theoretical calculation will just turns out that the some of the 10 to the minus 16 times of such a SATA term, or strong CP SATA, but the experimental boundary is 10 to the minus 26. It means that such a strong CP page SATA should be the extremely small 10 to the minus 10, and that if this is a very extremely fine tuning, and it is called a strong CP problem. Simply said, the CP page in the QCD is extremely small, and that's a very fine tuning. And the one possible way to resolve the strong speed problems is if the Koch mass is equal to juice, then the coupling between the pion and the nucleon doublets are extremely small. So the theta terms can be extremely small. But by the experiment, such as zero massless Koch is excluded. So the other possible way to resolve the strong CP problem is the Axion, which is introducing the additional axial symmetry to make the theta as a dynamical field. And also there are another way to resolve the strong CP problem, but I don't want to discuss it in this video. So now let's talk about the new axial symmetry, which is called the Parkinson symmetry. Parkinson symmetry is just written by the U1PQ, and this is actually the chiral or axial symmetry. And also such a U1PQ symmetry is spontaneous symmetry broken. So also the Goldstone boson fields that appear, and we will call this Axion, and this is also the angular field. So because this is triangular field, there is a periodicity, and we can parameterize such a periodicity as a shaped symmetry with the peak breaking scale of I. So by such additional Goldstone field by spontaneous symmetry breaking from the U1 peak symmetry, also the Axion fields are coupled to the field strengths of the gluons and each dual. So it makes the theta term becomes a dynamical field. One thing I want to mention is that actually the angles is given by the A over the FA by the periodicity, where the FA is the peak breaking scale. So if such terms theta plus AF over the is equal to 0, so extremely small, because the A is just a dynamical field, so that it can have the BAB as satisfied this quantity becomes a G. So such a dynamical fields actions can be provide a very small values of status naturally, so that they can resolve the strong speed problem. So and actually the Koch has a mass, so there are some additional terms in the chiral perturbation theory Lagrangian. Usually the chiral perturbation theory has such a term. Twice of the partial mu u Goldstone boson field, which is parameterized by the exponential forms through with the theta term. Another additional term, which has a Koch mass matrix. And by inserting this of the BAPs in the pions and the Goldstone boson field, it only remains terms the axion, and we can obtain the axion potential, and it has a Bernoulli form, and there are some several quantities dependence, like the pion mass and the pion decay constant, and the Koch mass and the actions physics scale. And by calculate the quadratic coefficients of the action potential, so we can obtain the action mass in terms of those similar quantity. And is the depends on some of the Koch mass and the pion mass and decay constants and axion physics scale. And because this is a QCD action to resolve the strong CP problem, so the axion mass is related with the mass of the Koch and the mason, and this determines the typical case of the QCD actions that are 10 to the minus 6 electron volt. And so the axion mass is has such a typical scale, 10 to the minus 6 electron volt, when the typical axion physics scale is given by the 10 to the tau of ZB. And also there are some other point of view instant terms because such anomalous terms, theta terms that comes from the some non-zeros right-hand side in the anomalous world identity, so that there are some non-zero term as a proportional to the G minus and the G dual. And by using the Atiyah-Singer index theorem, such as some of the non-zeros right-hand side, Bill's strong standard dual gives some of the integer changes of the some of the numbers, and it gives some of the instanton configuration. And in the simply, instanton is a vacuum to vacuum transition. So there are some of the multiple vacuums with some of the parameters that are. And to make the such a vacuum to vacuum transitions, the potential is given by the periodic potential. So we can construct the action potential to make the such a periodicity. It can has such a form with the cosine function, but to make the equilibriums is nearby the zero, so that there are one minus factors, and to make the action mass as a quadratic coefficients of the potentials, such a terms as multiplied. So the and the one thing I want to mention is the angle is given by the against the A of graph A. So near the A equal to 0, the action mass is becomes the coefficients of the quadratic derivatives of the potential. So now I come to some of the action cosmologies. In the previous ones, the motivation of the actions that comes from the strong speed problems and the QCD, but the action also can be the candidates of dark matter. But this is a very light mass, 10 to the minus 6 electron volt. So that this is quite light compared with the WIMP, which has almost a 100 gigaelectron volt or 10 electron volt scale, and such a WIMP dark matter is produced by the thermal breeze out by using the Boltzmann equations. But in the action case, is not produced by the thermal dark matter. There are some of the bound, and such a WIMP can be the cold dark matters to be constant with observational some of the measurement, but such a light mass of the dark matter becomes the very warm dark matter, and is not constant. So this is not produced by the thermal breeze-out. So the actions is actually the non-thermal dark matter. And the production of the actions is given by the misaligned mechanisms that I will explain now. First of all, the scalar built in the expanding universe and with the some of the spatial homogeneity, already we saw in some of the many videos, especially some of the implications theory. The equational motions of action fields are given by the such harmonious lattice equation. Please see some of the other videos to derive this equation. And there are some of the Blackian systems and Briggshian terms which comes from the Hubble's parameters. And if the Hubble parameters are larger than the axion mass, then it is frozen by the Briggshian term. So the axion field does not changes. But if the Hubble parameters become the smooth by the cosmic evolutions, then the Briggshian terms are negligible. So the axion fields are oscillated. And also one more thing is the amplitude of the oscillations that damps over the cosmic time. Because the amplitudes are proportional to the root of the law, where the law is energy density of the action with the kinetic terms and the potential term. And such energy density is reduces by the 8 to the minus 3, where the I is the scaling factor. So the action field oscillation amplitudes are damped over the time. So such behaviors of the action fields in the cosmic times are described like that. So before the when the Hubble term is extremely larger than the action mass, then the action fields are frozen. And when the Hubble becomes smaller than the action mass, it starts oscillation, but the damps over the time. And the such actions are produced by the misalignment mechanism, which is the initial conditions of the action field values that not in the equilibrium. So initial values are far away from the such equilibrium. So the action started in this has some of the specific values, and it becomes rolled down to the equilibrium point. And by these productions mechanisms, the action abundance is determined as a function of the breaking scales of the action and the action mass, and it should becomes to the 0.1 to explain the full abundance of the dark matter. And I want to mention the very briefly about the ARP, which is action-like particle. Such a ARP does not have some of the couplings with the gluon field, and it to resolve the strong TP problem. So the ARP mass does not come from the Chiral perturbation theory, so that it does not have the typical mass scale 10 to the minus 6 electron volt. So it gives us the wide parameters price of such ARP mass. And maybe this in the next videos we'll talk about some of the how the actions are detected through the ARPs are detected in the various observations or experiments in the some of the astrophysical or cosmological or lab experimentals method.